A to the fourth power
4. Okay.
plus 4a cubed b
Okay.
plus 6a cubed, sorry, 6a squared b squared
Okay.
plus 4ab cubed
Okay.
plus b to the fourth power.
Okay. Am I right? I have copied same.
Let me make sure really quick. Yeah.
Okay. Now, so if I start increasing the power, okay, if continuously if I'm increasing the power instead of a to the power 4, a plus b whole to the power 4, if I write 5, and slowly I started increasing and writing over here that a plus b whole to the power 100, then I start to write over here and going to a plus b whole to the power 1000, and then I said no need to go 100 or 1000. If I increase to 10 itself, now you can feel that how difficult it is to multiply continuously.
Yeah.
Yeah, it is very difficult. Up to 10 itself it will be very difficult. I'm not going to after 1000, it's so big. So what should I do now? Next question. So here in this case it is coming as binomial theorem. So binomial theorem has started or took place in this situation. To know this binomial theorem, you should know what is permutation, okay, and what is combination. Now the major thing is we should know what is combination. This combination will help you to develop this binomial theorem. The combination and permutation is notations are for permutation we write NPR and for combination we write NCR. There are few ways to represent it, has been written like this also, and for combination it has been written like this also. Now both are same to same. Now what do you have to do? When it's a permutation, we are using this P1 thing, P is NPR. NCR also can be represented in the form of N. Okay,
Yep.
so both representation are same. Now what there's a general formula for sorry general formula for binomial theorem. What is this general formula for? General formula is a plus b whole to the power n is a to the power n nc1. Okay, the first value it is coming. I'll come to the point what is nc1 and nc2 and what is that. A to the power n minus 1, b to the power 1, nc2, a to the power n minus 2, b to the power 2, and slowly if you develop coming to the last part, that is b to the power n. The power when n value is 100,000, 1,000, 10,000, whatever, 100,000, you can just place it over there. You will get a correct expression. Okay. Now to know about this part, especially NCR part, you should have a concept of factorial. Now what is factorial? I'm taking very new terminologies actually. Factorial. Now what is this factorial for? Now factorial has a two kind of notation. Factorial notation, you can represent it like that. This is called n factorial, or you can represent exclamation. That is also n factorial. Now what is the meaning of factorial? Factorial means chain of multiplication. What is this? Means it will start reducing. n, n minus 1, n minus 2, n minus 3, where it will end times 4 times 3 times 2 times 1. But after 1 if you put 0, 0 times any values is 0. So it cannot go to multiply 0, right?
Yeah.
So This is the expression for n factorial. So this is a very important formula. You can keep a note for this. Now I'm coming to the next part of this, as I said, that is NCR. What is NCR or NR? Within a matrix form or within a bracket form I'm writing. NCR formula is n factorial over n minus r factorial times r factorial. Okay. Now how this expression can be represented? Similar way as n factorial. If I write n minus r factorial, this is the meaning of n minus r, n minus r minus 1, n minus r minus 2, up to how many? Up to 4, 3, 2, 1. Okay. The similar way, if I say r factorial, what is r factorial? R factorial means r into r minus 1, r minus 2, r minus 3, up to how much? Up to 4, 3, 2, 1. Because there are so many values are there, we cannot write that many values. So that's why we are taking a help of dot. All the values are existing over there. Now take an example that how the factorial will work. Okay, how will you find a factorial? Suppose you are getting a value that is called 5 factorial. Now how you will find 5 factorial? 5 factorial means, as per the formula of n factorial, it is n minus 1, n minus 2, up to 4, 3, 2, 1. So we are going to use this one. So 5 minus 1, 5 minus 2, 5 minus 3, 5 minus 4. Now next one, if I write 5 minus 5, it is become 0, right?
Yeah.
So we are not going for that, because 5 minus 4 itself, the formula is saying, well, we should stop at 1. When you'll get 1, you should stop it. So 5 minus 4 is giving 1. So I should stop over there. So now what is the expression? 5 times 5 minus 1, 4, times 5 minus 2, 3, times 5 minus 3, 2, times 5 minus 4, 1. Now if you multiply 5 4s are 20, 20 times 3, 60, 60 times 2, 120. So my 5 factorial is 120. Similarly, if I tell you find 10 factorial, so 10 factorial means 10, 10 minus 1, 10 minus 2, 10 minus 3, 10 minus 4, 10 minus 5, 10 minus 6, 10 minus 7, 10 minus 8, 10 minus 9, because 10 minus 9 is giving 1. So I stop there. So ultimately 10 times, 9 times, 8 times, 7 times, 6 times, 5, 4, 3, 2, 1. Well, if you multiply this expression, whole expression, what you will get? You will get, multiply this, 3, 6, 2, 8,
800.
8, 0, 0. Okay. So
Yeah.
this expression, the factorial, that means 10 factorial will be this. Okay. Okay. Now this is a part of factorial. Now if I am giving an example of NCR, as we have already discussed, NCR formula is n factorial, n minus r factorial, and r factorial. Suppose you have an expression of suppose 5c2. So what should I write? 5 factorial over 5 minus 2 factorial, 2 factorial. What does it mean? 5 factorial divided by 5 minus 2 is 3 factorial, 2 factorial. So 5 times 4 times 3 times 2 times 1. If you make a factorial of 5, you will get this expression. Now 3 factorial means 3 times 2 times 1, and 2 factorial means 2 times 1. Now you can do cancellation of values. So you will get 10. So my 5C2 will be 10. Okay?
Yeah, I see that.
Yeah. Now next work is, if you are going to, so this is the way to find how this 5CR sorry NCR is working. Now coming to the point that how you are going to write a plus b whole to the power n. If I have a plus b whole to the power 5, because up to 4 already you have multiplied. So as per my formula, I should write 5 5C1 a to the power 5 minus 1 b to the power 1, 5C2 a to the power 5 minus 2 b2, plus 5C3 a to the power 5 minus 3 b3, plus 5C4 a to the power 5 minus 4 b4. Now next one is 5C5. We are not going because 5C5, and this formula also I am giving you, and then b to the power 5, because this is the highest power. A to the power 5, b to the power 5 will be there. Now 5 minus 4 itself is giving 1, so we don't have to process next one. Now what are the things I have used for this one? There are few more formulas you need to know. That NC0, whatever it will be, that will be 1. NCN, if both values are common, it will be 1. Okay, these two expression, and 0 factorial, that is also 1. So, and of course 1 factorial also 1. So these are the formulas together you have to keep in mind. Okay, now we are coming to the expression. Now 5C1, if you use the method of this 5C2, how it is coming, if your method is this, you will get 5 a to the power 4 b to the power 1. Already you have already done. 5C2 is 10 a to the power 3 b to the power 2, and 5C3, wait a minute, 5C3 is also 10, so 10 a to the power 2 b to the power 3. Now 5C4 is 5 a to the power 1 and b to the power 4 plus b to the power 5. So if I am going to multiply a plus, now I am going to take another one, that is a plus b whole to the power 5. Like previous we have multiplied. Now let's try a plus b whole to the power 4 into a plus b. Then check, if you multiply this two expression, are we getting this whole thing or something else?
Okay.
This is a checking. Are you getting this or something else? Okay. Check it.
Yep.